In this section, we're going to prove some identities, and to do these problems, you need to have memorized those basic identities, the reciprocal, ratio, and Pythagorean identities, and then we're going to put those identities together with a little bit of algebra and prove some more difficult identities. Here's our first one. We want to prove that cosine theta times tangent theta is equal to sine theta. So I'll start with the more complicated side, and I'm going to take cosine theta, tangent theta, and rewrite it as cosine theta times sine theta over cosine theta using my using my ratio identity that says tangent theta is always sine theta over cosine theta. Now I'll divide out the common factor cosine theta, and that simplifies into sine theta. So I've succeeded in taking this expression and with a little bit of identities from trigonometry and a little bit of algebra here, simplifying it into sine theta. So I've proved that cosine theta times tangent theta is always equal to sine theta. Here's our next one. I want to show that cosine x times cosecant x plus tangent x is equal to cotangent x plus sine x. So I think I'll start on this side, on the more complicated side here, and I'm going to apply my distributive property and multiply cosine x times both of these terms here. So when I do that, I'll have cosine x times cosecant x plus cosine x times tangent x. And let's see, I have cosine x times cosecant is 1 over sine x. So I can use that reciprocal identity. And then I'll have cosine x here times, I'm going to change this to sines and cosines using my ratio identity that tangent x is sine x over cosine x. Now I'm keeping an eye on this side. I want to change this side into this side, so I'm going to need a sine x and a cotangent x. I think I've got it here. Cosine x times 1 over sine x is cosine x over sine x plus, that's my plus sign here, cosine x times sine over cosine. I'll divide out that common factor of cosine and I have left sine x. And so I see I've succeeded in getting what I want here. Cosine x over sine x using my ratio identity, that's cotangent x plus sine x. And I've succeeded in changing the left side of this expression, of this identity, into the right side. So I've essentially proved this identity. So you can see by watching what I've done right here that you need to know those basic identities, reciprocal identities, ratio identities, and Pythagorean identities to be able to do these problems. Here's another one. I have cosine to the fourth t minus sine to the fourth t over sine squared t is equal to cotangent squared t minus 1. So I'm going to start with this side here, and I'm going to start by factoring the difference of two squares here, since fourth powers are also squares. And so when I do that, I'll get cosine squared t plus sine squared t times cosine squared t minus sine squared t. And that's all divided by sine squared t. Now I look and see here I have cosine squared t plus sine squared t, and I know that that is simply equal to 1. So I have 1 times cosine squared t minus sine squared t. So this is going to be equal to cosine squared t minus sine squared t all over sine squared t, using my Pythagorean identity that says that this is 1, so 1 times this is just it itself. Now let's see, I look over here, I want cotangent squared minus 1. Well, if I take this sine squared that divides this numerator and divide each term in the numerator by it, I'll have what I'm looking for. Cosine squared t over sine squared t minus sine squared t over sine squared t. And look what I've got here. Cosine squared t over sine squared t, that is cotangent squared t minus sine squared t over sine squared t is 1. So I've done the same thing here. I've succeeded in changing this side into this side using just trigonometric identities and a little bit of algebra. So I've proved this identity.